Hello guys, welcome back to a new video. In this video we are going to solve practice 3A. Now in the previous lesson we solved sample problem 3A. In this video we're going to solve the questions of practice 3A. The question 1, you have a piece of metal that weighs 50 Newton in the air. Now we learned that when we say the weight of the object in the air, we say it's Fg. So Fg in the air is equal to what? Is equal to 50 Newton. Okay. And 30 Newton in water. So you have F apparent. Okay. F apparent is equal to what? Or you can just simply write Fa. Fa. Okay, is equal to 36 Newton. Okay, and 41 in an unknown liquid. Okay, we will come back to this one in B, but let's first solve the first one. Find the densities of the following. It says what? Find the density of the following. Let's write the F for unknown. So this is what it says in the fluid. So this is F apparent, careful, Fa for the unknown fluid, okay? For the unknown liquid is equal to 41 Newton. Now look guys, it says find the density of the metal, A, and B, find the density of the unknown liquid. Let's first find A, okay? It says find density, so density of the metal is equal to what? Since it's water, guys, look, it's water, so we know also the density of the fluid too. So the density of the fluid is equal to what? Is equal to 1 times 10 to the power of 3 kilogram per meter cubed. Okay, now you have the equation of the finding an object that is sinking. Okay, so whenever the object is sinking, you'll be using this equation. Fg, let me write this in a different color. So you have Fg divided by what? Divided by Fb, which is equal to what? Which is equal to density of the object divided by the density of the fluid. Now guys, take a look at this one. Let's see if I have all the given givens here. Now, do I have Fg? Yes, I have Fg, which is equal to 50 Newton. Do I have Fb? No, I don't have Fb. But using Fg and Fa, I can find Fb too. So let's consider we have this one too. Do I need this? Do I have this one? No, I don't have this one. It's in the question. It says find the density of the object. What about the fluid? Yes, I have the density of the fluids too. I have the density of the fluid, which is equal to 1 times 10 to the power of 3. Now, as we learned in the previous lessons, let's use cross multiplication so that this one, this guy here, stays alone, okay? And then we can find it. Then you have Fg times density of the fluid equal to Fb times density of the object. Divide all of this by Fb, and this one also by Fb. Fb goes with this one, then you have this equation left. Rho naught is equal to Fg times rho f divided by what? Divided by Fb. Okay, now look at this one. Sorry. Guys, do I have Fg? Yes, I have. Now, how do I find Fb, guys? I have this one too. I have density of the fluid too. Take a look at this one, guys. You will say, most of the time, you have Fb, which is equal to Fg minus F apparent. Okay, careful. In most of the questions, you are going to use this one. But how do you get this one, guys? Okay, how do you get this one? Usually, we can say that F net, okay, is equal to Fg, which is the weight of the object in the air, minus the buoyant force, okay? Then we will say Fb is equal to Fg minus F apparent, okay? But you can just use this one too, okay? In most of the questions, when we are trying to find FB, we will be using this equation, okay? Now, let's put FG and FA here. FB is what is equal to FG. FG is how much? 50 Newton. What about the apparent weight? It's equal to 60 Newton. Then you have how much? You have 14 Newton. This is what, guys? This is F apparent. Now we found this one too. Let's put all the numbers in the equation. You have Fg, which is equal to 50 Newton, times what's the density of the fluid? 1 times 10 to the power of 3. Okay, divided what? Divided by 14 Newton. Okay, then the result will be what? Will be 3.57 times 10 to the power of 3 kilogram per meter cubed. Okay, guys, this is A. B, guys, it says find the density of the unknown fluid. Okay, how do I find the density of the unknown fluid, guys? By the way, the weight of the object, which is Fg, is still 50 Newton. Okay, and the density, guys, look, we found the density of the object, so I'm going to use it to find the density of the unknown fluid. 3.57 times 10 to the power of 3 kilogram per meter cubed. Okay, then we have what? We have F apparent, which is equal to 41. Sorry, FA is equal to 41. By the way, it depends on you. How do you write this one? Okay, you can write F in water, you can write F apparent, you can write just FA, as you wish. It doesn't make any difference. You have 41 Newton. Okay, it says what? It says find the density of the fluid. Let's do the same, use the same equation. We have what? We have Fg, which is the weight of the object, divided by the buoyant force, which is equal to rho naught, or density of the object, divided by the density of the fluid. Now, guys, let's take a look at this one. Do I have Fg? Yes, I have. It's here. Do I have Fb? No, I don't have Fb, guys. Using the same equation that we used in the previous question, we are going to find Fb2. Do I have the density of the object? This time, yes, I have the density of the object. I need to find this one. Let's rearrange the equation. Cross multiplication. You will say it's equal to Fg times density of the fluid, which is equal to Fb times density of the object. Now divide all of this by Fg, divide this one by Fg. Fg goes, remains density of the fluid alone. Then you have Fb times density of the object divided by Fg. Guys, if you don't know how to rearrange the equation, practice this a lot. You should be comfortable rearranging the equation as it is demanded in the question. Okay, it's easy, it just needs a little bit practice. Now let's find Fb for this one, guys. Fb is equal to Fg minus F apparent. Then you have what? We have 50 times minus 41. You have 9 Newton, guys. 9 Newton is what? Is Fb. Now look, guys, we will say what? We will say 9, which is Fb Newton, times the density of the object, 3.57. It's okay if you don't write the units too. Times 10 to the power of 3 kilogram per meter cubed. Only the final unit is important. Then you have Fg, which is equal to how much? Is equal to 50 Newton. Then you have what? 6.7 times 10 to the power of 2 kilogram per meter cubed. Okay, this is what? This is the density of the fluid. We have question 2, the second question. It says A 2.8 kilogram rectangular area mattress is 2 meters long and 0.5 meter wide and 0.1 meter thick. Guys, you can easily guess. You have length, you have width, and you have thickness, which is basically the height. Then this is asking for finding the volume. Okay, so to find volume here, you can just simply multiply all these numbers and you'll get the volume. What mass can support in water before sinking? It says what mass. You have the mass of the rectangular, guys. Then you have the mass of what of the objects that are going to stand on the mattress, and what mass can it support before it sinks. Okay, so you have M1, it needs M2, okay, which is the load mass on the mattress. Now let's write this one, guys. You have M, you can write M of the mattress, or you can write M1. Okay, let's write M of the mattress. Sorry, M of the mattress is equal to what? Is equal to 2.8 kilogram. Okay, now you have length, which is equal to 2 meter. You have width, which is equal to 0.5, and you have height, which is equal to 0.1. 0.5 meter, and you have height, which is equal to what? Which is equal to 0.1 meter. Now, it's what? It's water. It says water. So you have already the density of water, which is equal to 1 times 10 to the power of 3 kilogram per meter cubed. Okay, it says what, guys? It says mass of the, it says find the mass, let's just write mass of the load, okay, is equal to what? Now, guys, you can use an equation for objects that are not sinking, but they're either floating or standing in water. You will say FB, guys, careful. This is for finding the buoyant force on an object which is not sinking. So you will say FB, which is the buoyant force, is equal to what? Is equal to FG, which is the weight of the object. Now, if FB is equal to what? Is equal to mass of the water, okay, then then you have what? You have G, which is gravitational acceleration. Careful, F is equal to mg. Anyway you have force, it's equal to mg. Then you have what? You have mg here, okay? Now, guys, look. For weight of the object, we have two masses, okay? M is what? M is mass. You have two masses, guys. Mass of the mattress and mass of the load. Okay, let's write what now? Let's make this one two masses. Okay, we'll write M of the mattress. Let's just write MM, okay? Plus M of the load, okay? ML, okay? Then all multiply by gravitational acceleration. Now, as you know, this one goes with this one. Remains what, guys? Remains mass of the water, which is equal to which is equal to M plus M of the load. Okay, now, guys, I have mass of the mattress and I need to find mass of the load. But do I have the mass of the water? No. But do I have something to find the mass of the water? Do I have other what we call givens that I can put it here? Now let's take a look. I have density, guys, and I can find volume too. Let's find volume. Volume is equal to what? Volume is equal to length times width times height. Okay, then you have what? You have 2 times 0.5 times 0.1. This is all equal to what, guys? This is all equal to 0.1 meter cubed. Guys, we found volume. Now, guys, I have density and I have volume. Can you make any connection between these two? Yes, we have what? We have density. Density is equal to what is equal to mass over volume. Guys, I have mass here. Can I rearrange this equation and put it here? Why not? Use cross multiplication. Let's say 1 is here. And then you have what? You have mass, which is equal to rho times V. I have density, which is density of the fluid. And I have the volume too. Okay, so you will have what? You will have density multiply by what? Multiply by volume. Then you have what? M, which is mass of the mattress, plus ML, which is mass of the loads. Now, just put the equations, put the givens, and you will find what? And you will find mass of the load. You will have what? Density of the fluid is equal to 1 times, or let's just rearrange this equation. We need to find this one, so you'll put this one here. So you'll have what? You'll have ML, or M load, which is equal to density of the fluid multiplied by volume minus what? Minus mass of the mattress. Now ML is equal to what? Is equal to 1 times 10 to the power of 3 times 0.1 minus what? Minus 2.8, which is the mass of the mattress. Subtract all of this. You get 100 here minus 2.5. Sorry, 2.8. Then you get what? You get 97 kilogram. Approximately, by the way. Okay, this is what? This is mass of the loads before the object sinks. You have question 3. Question 3, it says a ferry boat is 4 meters wide and 6 meters long. When a truck pulls onto it, the boat sinks 4 centimeters in the water. This 4 centimeters, guys, is what is height. You have width, you have length, and you have height too, which is 4 centimeters. What is the weight of the truck, guys? It needs what? It needs FG. It's a really good question, and it's an easy one too. So you have what? You have width. Oh, let's erase this one. Sorry. Now you have what? You have width, which is equal to 4 meters. You have length, which is equal to 6 meters. You have what? You have height, which is equal to 4 centimeters. You should change it to meter, careful. Multiply by 10 to the power of minus 2, or you can just write 0.04 meter. Okay, you should change it to meter, careful. If you have centimeter, or if you have different units, your units should be consistent, careful. They should not be, one should not be meter and the other one should not be centimeter. They should all be meter or centimeter. Now, guys, look, it says what? It says, what is the weight of the object? So it needs what? It needs FG, okay? It needs FG. Now, as you can see, guys, it's what? It's water. Now, you know that the density of water is equal to 1 times 10 to the power of 3 kilogram per meter cubed. Okay, this is the density of water. Now, let's take a look at this one, how we can solve this one. As you might guess, we have this one. We can find volume using this one. Let's find volume first. Volume is equal to length times width times height. Then you have what? You have 6 times 4 times 0.4. Then you have what? You have 0.96 meter cubed. We found volume. Okay. Now let's see where can we use this one. FG, guys, as you remember, is equal to what? Is equal to, sorry, because this object is not sinking, okay, it's a ferry boat, and as you know, a boat is what? Is floating. Okay, now look, as we studied, as we did in the previous example, you will say FB is equal to what? Is equal to FG, okay? Then we have what? We have this one, okay? Which is what? Which is the buoyancy. Then you will say what? You will say FG, and buoyancy is equal to what? It's equal to mass of the water multiplied by G, okay? Do I have density of the fluid? Yes, I have density of the fluid. Now, remains only what? Let's write this equation like this, sorry. As we learned in the previous example, I'll just write this one like this. Okay, it's the same thing. Mass is what? Mass is equal to density of the fluid multiplied by volume, and then we have gravitational acceleration. Density of the fluid is equal to what? Is equal to 1 times 10 to the power of 3. Then you have volume, which is equal to 0.96. Then you have what? Gravitational acceleration, which is equal to 9.81. Then the final result will be 9.4 times 10 to the power of 3 Newton. This is what? This is the weight of the object, okay? This is question 3. Question 4. Question 4 is a good question too. Please pay attention to this question. An empty rubber balloon has a mass of what? Of 0.0120 kilograms. So you have mass of the balloon. Okay, let's just write mass B is equal to 0.012 kilogram. Okay, then you have what? The balloon is filled with helium. Okay, the balloon is filled with helium at 0 Celsius. It doesn't matter. 1 atmospheric pressure and a density of 0.179 kilogram per meter cubed. Okay. Now, the filled balloon has a radius of 0.5 meter. So radius is equal to what, guys? Radius is equal to 0.5 meter. It says, what is it says, what is the magnitude of the buoyant force acting on the balloon? So it needs what? It needs FB. FB is equal to what? Now, guys, you might know, we will be using the other one in the, in B, okay? The density of the helium, and the other one too. But let's first find A. Look, guys, it says what? It says, what is the buoyant force that's acting on this balloon? Now, as you remember, we said FB is equal to what? FB is equal to mg, which is m of the what? Mass of the air multiplied by gravitational acceleration. Now, as you remember, we said mass is equal to what? Mass is equal to density of air, guys, multiplied by v, and then we can say multiplied by gravitational acceleration. Now, as you know, density of air, guys, density of air is equal to what? Density of air is equal to, this is density of air, it's equal to 1.29 kilogram per meter cubed. Okay, this is density of air. Then you'll say what? You'll say FB is equal to what? Is equal to 1.29 times, we had volume. Okay, do you have volume, guys? How can you find volume? Okay, guys, you know a balloon is what? A balloon is a sphere. Okay, and we have radius. Think about it. Can we find volume using radius? Why not? Okay, use this equation. Volume is equal to 4/3 pi r squared, sorry, cubed. Then you have what? V, which is equal to 4/3 times pi, which is 3.14, times what? Times 0.5 cubed. Then you have volume, which is equal to what? Which is equal to 0.53 meter cubed. We found volume 2. Let's put it here. You have 0.53. Then, guys, multiply all of this by what? By 9.81, which is the gravitational acceleration. FB is equal to what? It's equal to 6.6 Newton. Okay, this is equal to 6.6 Newton. Let's solve B. Okay, now B, guys, it says what? It says, what is the magnitude of the net force acting on the balloon? Okay, it needs all the forces that are acting on this balloon. Okay, so you have what? You have density of helium, okay, H, let's just write H, is equal to what's equal to, as it's given in the question, 179 kilogram per meter cubed. Then you have V, guys, we found V2, which is 0.53 meter cubed. Then we had mass of the balloon, which is equal to 0.012 kilogram. Okay, it says what, guys? It says F net is equal to what? Now, as you remember, we said F net is equal to FB minus FG. Okay, now look, guys, FB minus what? Minus the weight of the object. Can I write it like this? Yes, I can say mass of the objects of the balloon multiplied by what? Multiplied by gravitational acceleration. Now look, guys, because you have two masses, I can say it like this. I can say mass is equal to what? Is equal to mass of the balloon, mass of B, plus mass of the helium, mass of H. Okay, then mass is equal to what, guys? Mass is equal to density multiplied by volume. Okay, then you can write this one as this. Okay, I have the mass of the balloon. Okay, I have mass of the balloon, which is equal to 0.012 kilogram. I don't have to write this one for this one, but for the helium, guys, okay, I need the density and the volume too. Okay, so I'll write this one like this: M naught is equal to M of the balloon, mass of the balloon, plus rho multiplied by V. Okay, and then you have what, guys? You have G2, which is gravitational acceleration. Okay, bring this and put it instead of M naught. F naught is equal to what? It's equal to FB. Instead of this one, write what? Write M of the balloon plus rho of helium multiplied by V. Then you have what? You have gravitational acceleration. Okay, now F net will be what? It will be, you have buoyancy, which is equal to 6.63 minus, you have mass of the balloon, which is equal to 0.012 plus density of helium, which is equal to 0.179 times the volume, which is equal to 0.53, all times 9.81. Then you have what? F net is equal to 5.6 Newton. This is, guys, for finding this is the F net of the balloon. Okay, I'll explain this question again, okay, because it's a little bit confusing. Here, guys, we have F net. F net is equal to FB minus FG. Okay, FB here, we found it here. Okay, as you can see here, FB is equal to 6.6 Newton. So you'll just leave it like this. We have FG, guys. Okay, for FG, guys, I have two masses, mass of the balloon and mass of the helium gas. I will write M naught. Then M naught, guys, can be written as the addition of two masses, mass of the helium and mass of the balloon. Okay, I already have the mass of the balloon, so I don't need to write rho multiplied by V. Okay, I'll leave it like this. But for mass of the helium, guys, I don't have the mass of the helium. How can I find mass of the helium? I can say rho multiplied by V. Okay, instead of writing this one, I can say rho multiplied by V. Take this and put it instead of this M. Okay, then you have what? Mass of the balloon plus density of helium multiplied by V. Or you can just, guys, find this one first and put it here and write mass of the helium. Then multiply by gravitational acceleration, okay? Add the numbers, plug in the numbers into the equation, and you'll get 5.6 Newton. This is it for today. In the next lesson, I'm going to solve section review 3.1. See you in the next video.